Hello students, hope you all are doing good. So today we'll see when we place an object in different positions. Okay, when we place an object in different position, where would be the formation of image, where would be the position of the image, and how the image would be, the enlarged image or diminished image, inverted or erect image, or real or virtual. Okay, today we'll see this entire table with all the different diagrams according to the different conditions. Okay, so let us go with the first principle or first question. The position of object would be in the middle of mirror and the F. Okay, between the mirror and F. So this is my clear diagram. I'll just draw one more diagram to explain you. So let us consider this is my mirror. Okay, this is my mirror and this is my principal axis and this is my pole P. Okay, point pole P. Now the question says the object should be between the mirror and the F. So let us consider my object is over here. Okay, my object is over here and the focal point would be somewhere over here and the center of curvature would be somewhere over here. Let us consider this. So now before that I can name this object as O, or I can name this as AB. Okay, either way you name it. So now let us consider two rays are initiating from this point. From the top of the object, two rays are initiating, two light rays. So one is traveling in this direction, okay, which is just parallel to the principal axis. Okay, this is the principal axis, and let us consider this ray is parallel to the principal axis. And one more ray, it is inclined ray. Okay, let us consider this is the inclined ray. So I can name this as R1, I can name this as R3. Why I am naming is R3, you can name it as R2, because it is in the rule 3, it is mentioned, this ray is mentioned as R3, so I am mentioning this R3. You can name it as R2. Okay. So now, I have drawn the two incident rays. Okay, these are the two incident rays. Now I have to draw reflected rays for this. Okay, for if the incident ray is striking the mirror at this point, it would reflect back in the same medium. So here where it is going, it would be passing through the focal point. Okay, it would be passing through the focal point because it is the incident ray is parallel to the principal axis. Now let us consider this ray. Okay, now I'll draw reflected ray for this. So it is passing in such a direction that it passes through the center of curvature C. Okay, center of curvature C. So you can observe that it is retrace. Okay, you can see in the clear figure over here. See, it is retracing. Okay, it is retracing. Incident ray and reflected ray are represented in same line. Okay, whereas here this is the incident ray and this is the reflected ray which is passing through the focal point. Now for the formation of image, these two lines should meet. Okay, two reflected rays should meet, but here what happening, these two are not meeting at each other. So what I'll do is, so no real image formation. Okay, no real image formation. So now what I do is, I'll just project inwards. Okay, the reflected rays inwards. This is a reflected ray. I am projecting it inwards. I am extending it inwards. So they are meeting at this point. Okay, so here would be my formation of image. Okay, on the mirror I can see the image on the mirror, not on the screen or paper over here. So which means where the image is forming behind the mirror. Okay, the image is forming behind the mirror. This is mirror and this is my image. So image is in the behind the mirror. Now how the image would be enlarged or diminished? You can clearly see the object is small but the image is larger. So which means the image would be an enlarged image, and image would be erect. Erect means straight. Okay, this is the arrow pointing, this is a straight object and the image is also straight. Image is also straight, which means the image is erect, which means straight. And I told you the image or something which forms on the paper or screen would be a real image in front of the mirror, but it is on the mirror, which means it is a virtual image, which means it's a virtual image. Now we'll see another condition which is on the focal point. Okay, the object would be on the focal point. So let us consider this is my focal point. Okay, this is my focal point. This is the pole P. This is the pole P, and here somewhere could be my center of curvature C. So now what if I draw? Okay, this is my object. I can name it as A and B. A, B. If it is directly on the focal point. Now similarly the two rays are ejecting. One is parallel to the principal axis and one is inclined. Okay, one is inclined. This diagram is not present in the textbook. Okay, so now these are the two incident rays. So I have to draw reflected rays for this. So it is parallel to the principal axis, which means it will pass through the focal point. It will pass through the focal point, and it is already inclined, which means it is going outwards. It is going outwards. So these are the two reflected rays. Okay, these are the two reflected rays. So they are not meeting at certain point. We don't know where they can meet. Okay, if they are two parallel, they will never meet. If there is some inclination that they can meet, if there is certain amount of deflection between two rays, then they can meet somewhere, but we don't know where they can meet. So the position of the image would be infinity. Okay, the position of the image would be infinity. They can meet at any point. Now the image is enlarged or diminished, we don't know, because we cannot find the image. And erect or straight or inverted, we don't know, because we can't find the image. Even real or virtual, we cannot determine this condition. Now we'll see third condition, which is between F and C. Focal point, center of curvature. Object is between focal point and center of curvature. So this is my mirror and this is the center pole P. So this is my focal point. Let us consider this is my focal point, and let us consider this is my center of curvature C. Okay, this is the center of curvature C. Now what if I am drawing object between these two? Okay, I can draw anywhere. It is not mentioning a center or midpoint, anything. So I can draw anywhere. So AB is my object which is pointing upwards. I am drawing just beside the C, center of curvature. Okay. Now what if I project two lines from this, two rays, incident rays. One is going parallel to the line, principal axis line. So it passes directly to the focal point. We all know this. And one is directly passing to the focal point. Which means the reflected ray would be parallel to the principal axis. Okay. So now these two rays should meet at one point to form an image. So where they are meeting at this point. Okay. So this is my A dash and B dash, which is nothing but my image. And where the image is forming? Behind the C. Okay. Beyond the C. Okay. So the position of the image is beyond the C. Okay. And the image would be an enlarged image. Okay. According to this image, the size of this image would be much greater than this. Okay. So that would be an enlarged image. And here you can observe this. The pointing is, the arrow is pointing upwards. But here the arrow is pointing downwards. Which means the image is inverted. And the image is real, because it is forming in front of the mirror. Here if I keep a screen, here I can see the image. Okay. So which means it is a real image. Now we'll see one more condition, which is on center of curvature. What if I place my object on the center of the curvature? So this is my center of curvature. I am placing the object here. So I can name this object as either A or B. Okay. So this is my mirror and this is the center point and the principal axis P. This is the principal axis and the pole P. Okay. So now what if I project two rays from the tip of the object? Okay. This is my object. From here to here is my object. Now what if I am projecting two rays as similar I did with the previous problems? So now the one ray 1, the incident ray is just parallel to the principal axis. Okay, just parallel to the principal axis. And one more ray, which is inclined ray, it is directly passing through the focal point. Directly passing through the focal point. Now, what if I draw? These are the two incident rays, right? Now I have to draw the reflected rays. They are striking the mirror at this point. Now what if I draw a reflected ray? The reflected ray which is parallel, the incident ray which is parallel to the principal axis, the reflected ray would pass through the focal point. The reflected ray would pass through the focal point. And here it is directly, in this incident ray is directly passing through the focal point, which means the reflected ray would be parallel to the principal axis. Okay, this reflected ray would be parallel to the principal axis. Now where the image will form? When two reflected rays meet at one point, there would be a formation of image. So I can name it as A dash and B dash. So this is my formation of image. Where the image is forming, you can observe that image is also forming on the center of curvature. Okay, image is also forming on the center of curvature. When my object is on the center of curvature, the image is also forming on the center of the curvature. So the position of the image would be on C. On C. And the image is same size. Okay, it is not enlarged or diminished. The image, see, if it is like 5 centimeters, then this also would be 5 centimeters. Okay, same size image formation. Now inverted image, but the image would be an inverted image. Okay, see, the arrow is pointing upwards, but here it should point upward here, but it is pointing downwards, which means the image is upside down. Upside down means inverted image, and the image is real. Why the image is real? Because it is not on the mirror or behind the mirror. It is on the screen or paper over here in front of the mirror, which means it is a real image. Okay, so now we'll have one more condition, condition number 5th, I guess, beyond C. What if my object is beyond C? See, let us consider this is my focal point F and this is my center of curvature C. So what if I place my object beyond C? Okay, I am placing the object here, somewhere here after C. Okay, so this is my object. I can name this object as A and B. So similarly, two rays are ejecting from this object. One ray is parallel to the principal axis. This is my principal axis. So it is parallelly going. So this is the incident ray. And one more ray is inwards, which is directly passing through the focal point. Okay, this ray is directly passing through the focal point. So these are the two incident rays. So we know this condition. So when incident ray is parallel to the principal axis, the reflected ray will pass through this focal point. The reflected ray will pass through the focal point. And if the incident ray is passing through the focal point, and if the reflected ray is passing through the focal point, then the reflected ray would be parallel to this principal axis. Reflected ray would be parallel to the principal axis. We know that wherever these two reflected rays meet, there would be a formation of image. So here my image is forming. A dash and B dash is my image. This is my image. So in this you can say that beyond C, the image is forming between F and C. Okay. If I place the object beyond C, my image is forming between F and C. The image is between F and C. The position of the image is between F and C. And the image is diminished. Diminished means compared to A and B, it is small. So I'll give you a simple example, not exactly the same. If it is 5 centimeters, then it would be a 2 centimeter image. Okay, it is getting smaller. Okay, not exactly at this particular ratio, but I'm telling you just for an example. Okay, it is smaller when compared to a original object. And you can already see the arrow is pointing upwards, but here the arrow is pointing downwards, which means the image is inverted and the image is real. Why the image is real? Because it is forming over here on the screen or paper, okay, not on the mirror or behind the mirror. I hope it is clear. Now the last condition is at the infinity. Okay, at the infinity. What if I keep my image after C, anywhere after C? Okay, so I am keeping somewhere far away. My object is over here. Okay, object is over here, A and B, and arrow is pointing upwards. So, and this is a dotted line because we don't know the exact distance. Okay, so infinity means like somewhere away. So let us consider one ray is projecting from this side and one ray is projecting from the bottom. The two rays are projecting from this object A and B. So one ray is going exactly parallel to the principal axis. This is my principal axis. So one ray is going parallel to the principal axis. Another incident ray is also going parallel to the principal axis. Okay, both the incident rays are parallel to the principal axis. Okay, now we know the condition. If the incident line is parallel to the principal axis, then it will pass through the focal point. It will pass through the focal point. So both the lines are passing through the focal line because both of them are parallel to the principal axis. So here if I keep a screen, I can see the image. Here I can see the image. But how would be the image? The position of the image is on the focal point. Okay, both of them are meeting at focal point. The position of the image would be here. Okay, here formation of here image would be on the focal point, and the image would be just like a point. Okay, just like a dot. Okay, just like a dot, because it is very far away. The object is very far away. It is not clearly visible on the screen. So the object would be just like a dot, and the image would be a real image. Image would be a real image because it is forming in front of the mirror on the screen, which means it is a real image. And you cannot consider point as a inverted or a straight. Okay, so that's why we cannot determine whether it's a inverted or a straight or erect. So it is just like an point. I hope you understood all this. Okay, thank you.